Welcome all of you. This is another video of Maths Made Easy. Here I'm back with the 7th standard topic once again. Okay, so this is a 7th standard topic. As you know, I'm doing ratio and proportions right now. Now I'm going to I have taken up ratio in the previous video in detail, and this is a video in which I shall be taking up proportions. Okay, so together it makes one full chapter. So here today in this video you will find all different sums that can be asked in the exams, that can be made practically from the chapter proportions. Do see the video from the beginning to the end. So the entire video will have all different types of questions in this chapter. There is a variety of questions in the chapter proportions. So let's watch. Now, firstly, what is a proportion? We have done ratios and we talked about, supposing I have 4 by 20. Then 4 by 20 can be written as a 1 by 5 when we reduce it. Okay, so the ratio becomes 1:5. Now that was a ratio. Now proportion is when two different ratios become equal. Okay, so if I have a ratio A is to B and I have another ratio which is C by D, if the two ratios that is, after you have brought it, if you have brought the two fractions to the simplest form and then they are equal, then they are said to form a proportion. Then this forms a proportion. Okay, so this is called, that is a proportion. Basically, I repeat, when two ratios are equal, it forms a proportion. So when we have A by B ratio is equal to C by D, one thing we have to remember, these two has to be of the same kind. Okay, and these two also has to be of the same kind. Okay, like this can be distance. Okay, only distances here, and this can be amount of petrol that has been used in covering this distance. So either they are of the same kind or they are of the same unit also. Okay, here this side also has to be the same unit or the same kind. That makes a proportion. Now how do we write a proportion? We write A is to B and then a set of double dots. Okay, and then C is to D. This makes a proportion. Okay, this is how we write a proportion. So it tells us clearly that this by this ratio is equal to this ratio. Now these two, A and D, are called the extremes. Okay, the two end ones, and these two will be called the extremes. This also comes under extremes. These two comes under means. Okay, so that is how it is formed. Now if I am given a set of two fractions and I am asked, is this in proportion or not? Let me take one sum. Okay, so you will know then. So supposing they are wanting me to check whether the following numbers are in proportion or not. So they have given me like this. See, 18, 10, 9 and 5. They have given me like this. So now they want me to check whether they are in proportion or not. There's no double dot here, there's no single dot here, nothing. Okay, but they write in a particular sequence. That itself tells us that this one and this one are the extremes and these two are the means. Now how can I check? Let me come to one method that I can check. See, I can make a fraction out of these and that gives me a 9 by 5 if I reduce. For this, it is already 9 by 5, so they are equal. That was the first method of checking whether they are in proportion or not. It goes by the definition. The other method that you generally use in schools is product of extremes is equal to product of means. Sometimes it is very quick, so we use it. Now, product of extremes, if it is equal to product of means, then these four are in proportion. Okay, now what is product of extremes? What is product of means? What do they mean by that? So product of extremes, if I want to apply here, it is 18 into 5. That is product of extremes. This is 10 into 9. Product of means is 10 into 9. As I said, the middle two values go under means. These two are the extremes. So both of them are giving me a 90. Hence it is the four numbers are in proportion. Okay, so that tells us they are in proportion. But let me tell you where this rule has come from. Why do we do that product of extremes is equal to product of means? Basically, if we write like this, if we write 18 by 10, that is the proportion way, 9 by 5. Now, if they have to be equal, that is, if they have to be in proportion, that is, if this statement, we have to say yes, these four numbers are in proportion, then actually, if after this, if according to algebra, if we multiply this, remember cross multiplication method, if we multiply this, that has to be equal to the product of this, that is 18 into 5 has to be equal to 9 into 10. That is exactly what we are doing here. That is why we always say product of extremes has to be equal to product of means, then the numbers are in proportion. Okay. Now let me do the same thing checking for little fractional values, because sometimes when you see a fractional number, okay, then you tend to confuse. Shall I apply the same method, where to put what and all? Okay. Now I've seen many students, when it comes to proportion ratios, they understand very well. When it comes to proportion, they are a little confused. They can do the sums, but then they actually don't know the meaning of proportion. Okay, so here they are again asking, is this in proportion or not? Okay, so what do? We have to apply the same method. Product of extremes is 3 into 4 and half. Just try to product of extremes. Okay, and then product of means, and that gives me 3 and half into 4. Now let me see, 3 into, this is 9 by 2, okay, 27 by 2. Here it is 7 by 2 into 4, okay, that is 28 by 2. No, they are not in proportion. Okay, since product of extremes is not equal to product of means, they are not in proportion. Okay. Now they can ask a question. Here they are saying find x. Now what do we have? Why do we have to find x? Let's see. So it is, and they have given us something like this. X by 4 is equal to 9 is to 12. They have given us like this. Okay, so now we have to find x. So basically they have told us that this is in proportion, because they are saying this ratio is equal to this ratio. So x by 4 is equal to 9 by 12. We can reduce it a little bit. Okay, 3 by 4. Okay, so x by 4 is equal to 3 by 4. Okay, so now if we cross multiply, we can cross multiply if we want, 3 into 4. So x is equal to 3 into 4 by 4. Yes, and that is x is equal to 3. Yes, so the value of x is 3 here if these are in proportion. Here is another one. Let's see. That says 1 by 13 is to x is equal to 1 by 2 is to 1 by 5. Okay, 1 by 2 is to 1 by 5. So they have again told us that these two ratios are in proportion. Okay, so what do we do? Here, how to proceed? So this is, see, 1 by 13 divided by x, then the x will come here, is equal to 1 by 2 divided by 1 by 5 is into 5 by 1, right? So now x is how much? If we 1 by x, I'll leave the x here. Okay, that is 5 by 2, and let me take the 13 up. Okay, so now how much is x? If I do a reciprocal, even then I can find x, that is 2 by 65. Okay, so that is my value of x. The number is not a very good one, so because the question had all fractions, so that is my answer. 2 by 65 is the value of x here. Okay, now here I have 3.6 is to 0.4 is x is to 0.5. Then 3.6 is to 0.4 is x is to 0.5, then I have to find the value of x. I took up this sum because it had decimals. So what I'll do, first I'll write it in the proper manner. 3.6 is by 0.4 is equal to x by 0.5. Now this can be a very disturbing thing. Okay, so what I'll do, I will multiply with 10 and up and down. Remember, if I multiply above, I have to multiply below also in the denominator. When I multiply with 10, the point goes and I get this is equal to x by 0.5. There is one point remaining still. Let's see how we can manage it. This one I can cancel, it makes a 9. So x is equal to 9 into 0.5, which is, first I do 45 and then I'll place the point here. So x is equal to 4.5. Okay, so this is how we can find the value of x in decimal numbers. In this chapter, there can be some confusing terms like continued proportion. Okay, continued proportion. These are some of the continued proportions. Now this is one term which keeps coming in this chapter. Now what is it? If I have A, B and C, they are all in the same units, okay, then we can apply continued proportion, which is A is to B, okay, A is to B can be equal to B is to C. A is to B can be equal to B is to C. Okay, if A is to B is equal to B is to C, then these three numbers are said to be continued proportion, in continued proportion. Now how do we write it? A by B is equal to B by C. This is how we write it. Or we can also write B square is equal to AC. Okay, so these are the three ways of writing continued proportion. Okay, now what is so special about continued proportion? This mean is same. Okay, the mean term is same. So the B is called the mean proportional. Okay, B is called the mean proportional. Then A is called the first proportional. Okay, A is called the first proportional and C is called the third proportional, as you can see from the positions. Okay, so sometimes they just say the third proportional value is this much. So C is the third proportional. Let me do one sum on this. Find the third proportional to rupees 4 and rupees 12. Here, how do we handle this? Rupees 4 and rupees 12, find the third proportional. Now in this, we'll have to understand that since they have given us only two numbers, that means this is one continued proportion question. They are asking for the third proportion. That means these two becomes like this. 4 is to 12 is to x. Okay, it becomes a sum like this, which can be again written like this. This is how we should write it. So you see the mean proportion is being repeated. Okay, so now how do we write it? 4 by 12 is 12 by x, make it 3 here. Okay, x is equal to 36. Okay, x is equal to 36. Now check whether 7, 49 and 343 are in continued proportion or not. What will we do? Okay, so if we have to check this is in continued proportion, we'll have to take 7 is to 49 has to be equal to 49 is to 343, right? Now we have to show whether this fraction is equal to this or not. Okay, how do we show that? So 7 by 49 is equal to 1 by 7. 49 by 343, that is if you cancel with 7, 7 4s are 28, 9 again 7. is equal to 1 by 7. Hence, 7 is to 49 is 1 by 7. 49 is to 343 is also 1 by 7. Therefore, continued proportion. So, in continued proportion, you just have to learn to write them. Okay. You have to learn to write these three numbers, keeping the middle value equal. You'll have to place them like this first. That will make your work very easy. Don't try to do the sum from here, it will go wrong. So first write it like this, then do the sum. Now here is a question. At a particular time, the shadow of the pole of a building and a building are 1.7 meters, and this is for the building, this is for the pole. Okay, if the height of the building is this, find the height of the pole. Now why are they talking about shadows? Okay, that is one thing to understand, and this word is very important in this sum, at a particular time. Why? Because we have to understand that the ratio between the heights of two things is equal to the ratio between their shadows at a particular time. Okay, that is the ratio between the heights of two buildings at. So as you know, as the time of the day proceeds, morning shadows are longer. Okay, at noon shadow becomes very short, and in the evening again the shadows become long. So here they are trying to tell us that they have been measured at a particular time. Now at a particular time, as I said, the ratio between the buildings, ratio between the heights of the buildings will be equal to the ratio between the length of their shadows. Okay, so what will take, let the height of the pole be x. Okay, let the height of the pole be x. Then x, height of the pole, by 21.9, that is equal to, now if I have written pole's height here, I'll write pole's shadow here. Okay, remember, don't do it the other way around, you'll go wrong. And this is height of the building, so here it is shadow of the building. Now whenever I have to do a sum like this, what I'll do is I will simply multiply with a 10 so that I can remove the point. So x by 21.9 is 17 by 73. Okay, now once I do 17 by 73, I can take this x is equal to 21.9 into 17 by 73. Okay, now this 73, I can see that if I multiply with a 3, I'll get 219. What I'll do is I'll just remove the point, I'll multiply with a 10. If I multiply with a 10 above, in the next step, I have removed the point. But then I'll have to give a 10, I'll have to multiply a 10 in the denominator also. So I am trying to tell that I've multiplied with a 10, so I have removed the point and the denominator 10 is showing here. Okay. So here if I multiply, this is a straight 3. So this becomes 51 by 10, which is 5.1. Okay. So how you divide with decimals, I have a video for that, you can check that video. So 5.1 is the height of the pole. Therefore height of pole is equal to 5.1. don't forget the unit, it is a meter. So this is one sum which is very typical of this chapter. So what we have to remember is ratio between their heights is equal to ratio between the length of the shadows. Okay, if you remember this, we will get this sum. Basically the heights are in proportion to the shadows, you can say like that. Okay. Now the ages of Amit and Archana are in the ratio 4:5. If Amit is 4 years 8 months old, find the age of Archana. So they have given the ratio. So let Archana's age be x. That is what we have to find. Okay. So here they named Amit first. So we'll put 4 years 8 months. Now how to put it in months? 4 years is 48, 4 into 12, 48 plus 8. 48 plus 8 is 56. Okay, so we'll write 56 because we can't take two numbers in ratios. 56 by this is Archana's age be x, then it is 56. This is Amit's age. Amit's is 56 months as I have seen. We'll put Archana's age here, and then we are going to put 4 by 5 because they named Amit first, so 4 by 5. Okay, so x is equal to 4. So we can write it as a 4x is equal to 5 into 56. X is equal to 5 into 56 by 4. Okay, so 4, this is 14. So now it is a 70 months. That's not the end of the story. We'll continue. Okay, so 70 months is how many years? We'll have to get that. Okay. So 70 months, if I divide with a 12, okay, 70 if I divide with a 12, I am going to get, okay, that gives me 70 months can also be written as, so Archana is 5 years, 10 months old. Okay, so you also have to convert it to years and months and give it. Okay, then that is it from this chapter of proportions, from the proportions part of it. This is all that can be asked from proportions. Proportions is not very difficult if you understand the concept, and the calculations are always pretty simple. So there's nothing much other than continued proportion, mean proportion, product of means is equal to product of extremes, and few very simple problem sums. Okay. So in ratio and proportion, remember one thing, the sequence of the numbers matters a lot. Okay, don't change the sequence and just copy them because they are not random numbers. The sequence has to be kept same all through the chapter. That's a very common mistake, so I thought I'll mention here once more. Okay, so that is it for today. If you have liked the video, do not forget to like, share and subscribe. You will get the decimal, the videos for decimal multiplication and division in the description box. Do send a comment if you have liked the video. Thanks all of you. Bye then.